Black holes.
Black holes don't just pull on objects, they literally bend space-time itself. According to general relativity, gravity is not a force pulling things inward. It's mass warping around the geometry of space-time, like a heavy ball bending a stretched rubber sheet.
Near a black hole,
This curvature becomes extreme, bending the path of light itself. Light from behind or around the black hole can get curved towards us, creating bright rings or arcs. These rings exist because some light orbits the black hole multiple times before escaping, creating multiple stacked images of the same light source. Scientists call these photon rings, or lensing rings. That's why black holes can look like they have multiple slits, or arcs of light. You are actually seeing distorted copies of the same light source from different orbital paths around the black hole. The bright ring surrounding the dark center, the shadow, comes mainly from the gravitational lensed photons orbiting just outside of the horizon event.
I get that, Tars. All right, but we've got to figure something out, all right? The people on Earth are going to die. Think.
Cooper, they didn't bring us here to change the past.
Say that again.
They didn't bring us here to change the past.
All of this is one little girl's bedroom, every moment. It's infinitely complex. They have access to infinite time and space, but they're not bound by anything. They can't find a specific place in time. They can't communicate. That's why I'm here. I'm gonna find a way to tell Murph, just like I found this moment.
How, Cooper?
Love, Tars, love. It's just like Brand said. My connection with Murph, it is quantifiable. It's the key.
What are we here to do?
Find out, tell her.
the Higgs particle.
The Higgs particle exists because the math describing the universe basically demanded it. When a physicist built the Standard Model, the framework that describes all known fundamental particles and forces except gravity, they ran into a massive problem. The equation only worked cleanly if particles had zero mass, meaning electrons, quarks, and everything else that makes up matter shouldn't be able to slow down, clump together, or form atoms. But obviously, the universe doesn't have structure. To fix this without breaking the symmetry and the elegance of the equations, physicists including Peter Higgs proposed something radical, an invisible field that exists everywhere in space, even in complete vacuum. This field, later confirmed experimentally at CERN, is now called the Higgs field. In quantum physics, particles aren't little solid balls. They are excitations or vibrations in underlying fields. The Higgs boson is basically a ripple or vibration in the Higgs field itself, like a splash proving water exists, even though you can't see the ocean around you. Here's the deeper, more mind-bending part. Mass is not just something that objects have, it's something that happens to them. As particles move through the Higgs field, they interact with it, and that interaction resists their motion. A stronger particle interacts with the Higgs field, the heavier it appears. Some particles, like photons, light, don't interact with the Higgs field at all, which is why they have no rest, mass, and always move at light speed. Others, like top quarks, interact extremely strongly, making them incredibly heavy. Without the Higgs field, there would be no stable matter, no chemistry, no stars, no planet, no biology. The universe would just be a chaotic soup of massless energy moving at light speed. In a very real sense, the Higgs field is part of what allows reality to hold shape. What makes the Higgs concept philosophically wild is that it changes how we think about empty space. Vacuum isn't truly empty. It has structure, energy, and properties. The Higgs field has zero value even when no particles are present, meaning the universe has a kind of invisible background, condition that everything exists inside of. Instead of particles being fundamental and space being empty, modern physics suggests fields are fundamental, and particles are temporarily localized vibrations. Reality at the deepest level may be less like objects moving through space, and more like patterns forming an invisible cosmic medium. And here's the question. If the Higgs field gives particles mass simply because they exist inside of it, what if other undiscovered fields exist that give rise to properties we don't even realize are assigned yet? Could consciousness, time perception, or even the arrow of time itself one day be explained as interactions with deeper, current invisible fields, the same way mass was once mysterious before the Higgs field was discovered? When we talk about the brain, one of the biggest misconceptions is that it records reality the way a camera does. It doesn't. Modern neuroscience shows that the brain is not a passive receiver of information, but an active predictive system. At any given moment, your brain is generating expectations about what it thinks the world should look like, sound like, even feel like. And then it compares those predictions to incoming sensory data. This idea is supported by predictive processing and the Bayanese brain models, which show that perception is essentially the brain's best statistical guess about reality. Sensory input doesn't create perception by itself. It updates as an internal model that already exists. Memory works the same way. Neuroscience has demonstrated that memory is reconstructive, not reproductive. When you remember something, your brain is not replaying the past. It's rebuilding it using fragments stored across different brain regions, especially the hippocampus and the cortex. Each time a memory is recalled, it can subtly be altered by your current emotional states, belief, and new information. This is why eyewitness accounts change over time, and why two people can remember the same event differently, even though neither of them are lying. Factually speaking, the past you experience is always a reconstruction, a model designed to be useful, not perfectly accurate. This is where the probability wave analogy comes in. Not in a literal quantum sense, but conceptually. At every moment, your brain holds multiple possible interpretations of reality, weighs them based on past experiences, and settles them on your most likely one. Optical illusions prove this. Your brain chooses the interpretation that has been statistically reliable in your past. Even when it's wrong, decision-making works in the same way. Outcomes are assigned probabilities and values based on reinforcement learning. Conscious experience, then, is a result of constant updating process, a moving average of past information, present input, and future prediction. So in that sense, the present moment you experience is not a raw slice of reality. It's slightly delayed, heavily processed, and built from probability-weighted information. The past isn't gone, but it isn't stored as a fixed object either. It's a flexible model that your brain continuously reshapes to guide future behavior. In that sense, who you are right now is not a static identity, but an evolving prediction shaped by memory and expectation. So here's the question. If your brain is constantly predicting reality instead of directly experiencing it, and if your memories are reconstructed instead of replayed, then what if consciousness itself isn't just observing reality? What if it's actively seeking which version of reality you experience out of countless possible interpretations every second? And if intelligence is just really the ability to build a better predictive models, then at what point does a system stop predicting reality and start trading it with its experiences? And if that's true, how would you ever prove that the universe you experience isn't partly something your own mind is helping generate?